All right, so we've seen this before, that the conservation of energy, it cannot be created or destroyed. Energy is always there. We can just transfer it from one into another. So in Jane's case, in the previous problem, she had a bunch of stored elastic energy that was then transferred into the energy as form of kinetic and gravitational, since that bowling ball ballista was off the ground. So how does the energy change as a pumpkin falls? Well, if you notice, you have 5 meters and we're off the ground and we haven't moved yet. So in other words, all of our energy is going to end up being gravitational energy. Right there, we have 1, 2, 3, 4 bars. A little over 4 bars of energy, and it's all gravitational. This means, since we're right here at 4 bars, we have to have 4 bars in this situation, and we have to have 4 bars at the ending situation. Okay, so if you move here, we have cut our height in half. If you cut your height in half, remember the equation, mgh. If our height goes in half, it's also going to cut our energy in half. So we're now going to have half of our energy that we had in this situation. So, and since it's falling, it is now moving, so we have half kinetic, half gravitational. If we would only fall in a meter or so, we'd only have a fifth of our gravitational energy gone, and a fifth of it as kinetic. But notice there's 1, 2, 3, 4, 4 bars, 1, 2, 3, 4, 4 bars, they are conserved. Okay, the last situation, notice we're not off the ground at all, so we will not have any gravitational energy. So all the energy happens to be in kinetic. And we're assuming, obviously, this is right before it hits the ground. And even if it does hit the ground, this pumpkin is probably going to shatter, and it will go in all different pieces, which is also still things are moving, that is kinetic energy. Now, we can figure this out number-wise as well. If you look at, we have A, we have B, and we have situation C. We can figure out how much we have. Notice we are moving, and we are off the ground. So we are going to have both kinetic and gravitational energy. We have 1, 2, 3 bars of gravitational and 1, 2 of kinetic. Okay. At this point in time, we've rolled down the hill. We have all kinetic. Notice we are not off the ground at all. So all of this energy was then transferred into here. So that's 1, 2, 3, 4, 5. We should have 5 bars of kinetic. And in fact, we have 1, 2, 3, 4, 5 bars of kinetic energy. And we have the same amount, which means we're going to need 5 bars over here as well in situation C. Okay, now notice we are off the ground, so we do have some gravitational energy. Notice we probably are going to be moving, and so we will have some kinetic. So how do we figure that out? Okay, notice we just have more kinetic than we do gravitational, but once again, we have 1, 2, 3, 4, 5 bars as we did here. Now, we can figure this out number-wise as well. So how much energy, total energy, does the system start with? Remember, total energy is your mechanical energy, which is all the potential added to all the kinetic. So we need to add up our potential here of gravitational and our kinetic energy. Okay, so 1/2 mv squared is our kinetic, plus mgh, which is our gravitational. We found out that we're moving, mass is 800 kilograms, we're moving at 10 meters per second, so we got to square that, plus 800 times 10, rounding 9.8, as with an 80 meter height. You add all that up, 40,000 plus 640,000, you get a total energy of 680,000 joules, which means in situation B, we're going to have 680,000 joules, and in situation C, we're going to have 600,000 joules. This is the conservation of energy. How much kinetic energy does the cart have at point C? We're trying to figure out how much kinetic is here. We know how much kinetic is in B. That's easy. It's 680,000 joules. Okay, because all of it's kinetic. But C is going to be a little different. So what we do know is that the total energy, once again, we're just going to use this same equation. The total energy is 680,000. So we're going to put 680,000 in for this number. We know our height. We know gravity is still 10. We know the mass of the object is still 800. So we know mgh. And so really, whatever number this is, that's going to be what's left. Okay? So 600,000 equals our kinetic energy, which is the same as this, plus our mass times our gravity times our height, which is 800 times 10 times 35, we get 680,000 joules equals our kinetic energy plus our gravitational energy, which is 280,000 joules. We minus over 280,000, our kinetic energy is 400,000 joules. Now, given that it's 400,000 joules, we then could figure out our velocity at this point. We just plug it in for here. We know the mass of the object. We could solve for velocity.